What we're going to do now is use Pascal's triangle to expand a couple of binomials so you can see how that triangle works to help you raise x plus 2y to the fifth power. Now if you have your Pascal's triangle chart that we just filled out a minute ago, you can use that as reference, but chances are you're not going to just carry that with you wherever you go. So if you need to expand x plus 2y to the fifth when you get into another math class later on, I want to show you a quick way to recreate Pascal's triangle. I start always with the coefficients, so I would put a 1, and then I know that the next row has a 1 and a 1, and then from that point the coefficients start with a 1, and then you add these two, so you get a 2, and it always ends with a 1. And then the next one, start with a 1, add these two numbers, so you get a 3, add these two numbers, so you get a 3, and then end with a 1. And then the next row, we start with a 1, add the numbers, add the numbers, add the numbers, end with a 1. Start with a 1, add the numbers, add the numbers, add the numbers, add the numbers, end with a 1. We'll do one more row. Start with a 1, add your numbers, add your numbers, add your numbers, add your numbers, add the numbers, and end with a 1. Now, I will usually just go ahead and write, this would be a plus b to the 0. This will be a plus b to the first, a plus b to the second, a plus b to the third, a plus b to the fourth, a plus b to the fifth, a plus b to the sixth. Now if I were actually doing this to work on this expansion, I would only fill in that a plus b to the fifth row. Once I have my coefficients all written out, then I know that the first term here has a to whatever power I'm raising it. Since it's to the fifth, it will start with a to the fifth, and then the a's decrease by 1 each time I move to a new term until my last term doesn't have any a's. And then I start with my b's. On the right hand end, that will be to the fifth, which is the same as that row, and then to the fourth, and then to the third, and then squared, and then b. And remember that each term, we need addition signs in here, each term should have a total of 5 powers. So we have 4 and 1, 3 and 2, 2 and 3, 1 and 4, 5. So those degrees are all 5. So that would be the row that I'm using to expand x plus 2y to the fifth. So then I'll use that kind of like a formula. I need to notice that in my formula it says a plus b to the fifth, so that this x will be in the a spot and then 2y will be in the b spot. So I might write this row out: 1a to the fifth plus 5a to the fourth b plus 10a to the third b squared plus 5, I need a 10 there again, sorry, 10a squared b to the third plus 5ab to the fourth plus 1b to the fifth. And then I'm going to start replacing the a's and b's with the x and the 2y. So I'll have 1 times a to the fifth, a is x, plus 5 times x to the fourth times b, which is 2y, plus 10 times a cubed times b squared, plus 10 times a squared times b cubed, plus 5 times a times b to the fourth, plus 1 times b to the fifth. Now, for the purposes of showing you how to do this, I'm going to multiply out each of these. I'm going to apply each of these powers so that you can see what I'm really multiplying. So I'll have 1 times x to the fifth power is x to the fifth, plus 5 times x to the fourth power is x to the fourth, and then times that 2y, plus 10 times x raised to the third power is x cubed times 2y to the second power would be 2y times 2y, so that's 4y squared, plus 10 times x to the second power is x squared times 2y times 2y times 2y will be 8y cubed, plus 5 times x times 2y times 2y times 2y times 2y is going to be 16y to the fourth, and then plus 1, 2y raised to the fifth power is going to be 32y to the fifth. And then finally, I'm just going to multiply each of the terms by the three factors they're made up of, and then write that on my final row, which will be the answer to this expansion. So when it's all said and done, x plus 2y to the fifth is going to be x to the fifth plus 5 times x to the fourth times 2y is 10 x to the fourth y, plus, multiply that, I get 40 x cubed y squared, plus multiplying that out gives me 80 x squared y cubed, plus 80 x y to the fourth, plus 32 y to the fifth. So if I were to actually FOIL this out 5 times, I would get x to the fifth plus 10x to the fourth y plus 40x cubed y squared plus 80x squared y cubed plus 80xy to the fourth plus 32y to the fifth. It's worth doing one more problem because I do want you to see what happens when you have a negative in your expansion, in your binomial. So let's look at 2x minus 5 to the fourth power. Since we already have our triangle somewhat written out up here, I'm just going to go back up to the fourth row and fill in the variables so we can just use that. So we'll start with a to the fourth, a cubed, a squared, a, and then backtrack, b to the fourth, b cubed, b squared, b. Put my addition signs in there. And then my row is going to be 1a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the fourth. Okay. So let's go ahead and figure out what a and b are. In this binomial it says a plus b to the fourth. So what I need to pay attention to is that a is going to still be that first term, 2x, but this time I need to watch this negative. B is actually negative 5. So in my expansion, 2x minus 5 to the fourth, it's going to start with 1 and then a to the fourth, so 2x to the fourth, plus 4a to the third b, so 4, and then a was 2x, so 2x to the third, and then b was negative 5, and then plus 6 times a squared, so 2x squared, times b squared, negative 5 squared, plus 4 times a, which was 2x, times b to the third, so negative 5 cubed, plus 1 times b to the fourth, so negative 5 to the fourth. Then I'll do a similar process to what I had done before and figure out how each parenthesis looks after it's got that exponent applied. So this will give me 1 times 2x to the fourth would be 2 times 2 times 2 times 2, so 16, and then x to the fourth. Then I have plus 4 times 2x cubed would be 8x to the third power times negative 5 plus 6 times, that will be 4x squared, and then negative 5 squared is positive 25 plus 4 times 2x times negative 5 to the third power is negative 125, and then plus 1 times negative 5 to the 4th power is positive 625. Then I'll multiply these together. So I have 1 times 16x to the 4th is 16x to the 4th power. Then I have 4 times 8x cubed times negative 5. So that term is going to be negative, and 32 times negative 5 is negative 160x cubed. Then I have 6 times 4 times 25, which is positive 600x squared. 4 times 2 times negative 125 is minus or negative 1000x, and then that's plus 625. So be very careful if your binomial includes a negative that you watch the signs when you're applying your exponents, and remember that anytime you take a negative number raised to an odd power, you get a negative term, but a negative number raised to an even power gives you a positive term. So our negative 5 to the 3rd gave us a negative 1000, but our negative 5 to the 4th gave us a positive 625.